Good morning, everyone. My name is Rayford de Guzman,
Afternoon.
My name is Tomoaki Masudu.
and today I will present to you the future of the human race. Imagine the world 35 years from now. What if pandemics, climate change, war, and many other factors, what if they wipe out the human species off the face of the earth? We need to plant the seed of life. Our proposed NOAH'S ARK project, this is the proposed future of mankind. We will transfer people from the Earth to the Moon by means of self-sustaining construction buildings called arcologies.
So, why do we transport human to the moon? Who is he? Actually, he is Elon Musk, the CEO of SpaceX, and he said, Mars colonization is extinction insurance. What insurance for? These are factors showing we need the insurance, and each factors are related so closely, and we are showing why these are so important and so serious. First serious problem is increasing population. As you can see, in 2050, the population will be increased to 9.6 billion. And also, global warming can be one of the most considerable things, and only 1 or 2 degree increasing can cause many other problems in any aspects. And lastly, we might be destroyed by ourselves. So, World War III, including the usage of nuclear bomb, will destroy our lives and our society. Einstein said, I know, not with weapons World War III will be fought, but World War IV will be fought with just sticks and stones. It means the end of civilization. Now you understand why we have to do that. Next, why the moon? Why not the Mars or other planets like Venus? We have many criteria to choose them. Next is the chart showing which is preferred, and we can say that many aspects. We can say that many aspects. The Mars is superior to the Moon, but it's okay. Just importance is distance. Yes, distance is the most important because people living in the Moon can be helped by the people living on Earth. In contrast, people living on Mars can't. This is the important point, and that's why we choose the Moon.
So we already said the reasons why we should do it. Now, how will we do it? So we will, in order to reach the moon, we need to have a launch vehicle. This is similar to the rockets used in space exploration. This is our proposed diagram of the structure of the launch vehicle. We have the payload section, the engine section, and the nozzles. It's for thrust. We will use a special technology called antimatter catalyzed nuclear pulse propulsion. Now it sounds like a very big word, but we will try to explain it in simple terms. So first, there's a phase 1 in the engine section. It's called the annihilation chamber. In quantum mechanics, there's a theory that for every particle, there is a corresponding antiparticle. If a particle meets with an antiparticle, they undergo a process called annihilation. Now we theorize that due to the conservation of energy, when annihilation happens, tremendous energy can be made. So there, we have an antiproton of antihydrogen. We will collide it with a proton of uranium, and this will trigger a series of nuclear fission, which will produce a tremendous amount of energy. So why do we need this tremendous amount of energy? Because we will need this engine. to launch a very heavy structure like our arcology into space. Now, after creating that tremendous energy, we will have that energy go through the boiler, the liquid hydrogen, and it will power our steam turbines that will produce the electrical energy required. Now, let's go to the payload section. So, the payload section, this basically contains the arcology. So, we have three sections. We have the outer layer of the payload, we have the inner layer, and we have the arcology itself. So, after reaching the low Earth orbit, which is the part of the Earth where artificial satellites are naturally revolving, after reaching it through the engine section will disintegrate. And the only thing that will be left is this payload section. This payload section, what it will do, it will go to the lunar orbit, it will enter the orbit. After entering the orbit, the outer layer of the payload section will disintegrate. After it disintegrates, the inner payload layer, it reaches the orbit, it goes near the surface of the moon. And this inner payload layer then drifts away again, so that the arcology will land safely on the moon through titanium stilts. Now, the question is, where in the moon will we land? We plan to land on the north and south poles of the moon. Because in the north and south poles of the moon, we have hydroxide deposits. These hydroxide deposits, when reacted with water, when reacted with hydrogen, will produce H2O, which is a very, very valuable reason for an arid environment like the moon. Now, we're finished with how we will launch it and get it to the moon. Now, how will we construct the arcology itself? The outer structure of the arcology will be constructed in an arch shape with a strong outer layer. It will have a framework of cast regolith, which is Kevlar reinforced. Why do we need to use cast regolith? Cast regolith is a material that is very lightweight yet resistant to abrasion. But the thing is, it has a very low tensile strength. That's why we need to reinforce it with Kevlar. Kevlar has a very high tensile strength, so by reinforcing it with Kevlar, we can strengthen its weakness. The outer layer of the arcology will be covered with solar cells for alternative energy, and it will also be plated with transparent zirconium. Zirconium is a very dense element known to be very resistant against cosmic radiation. Now, why arch-shaped? It is arch-shaped so that when there is an impact in our structure, this impact will be distributed evenly. It will not possess any corners, as any corners is considered a weak point when it comes to impact. Now, we have already sent to you the outer structure. What about the inner structure? There's a study that for every living person in space, he should have a corresponding 120 cubic meters of living space. So, we're planning to send 100 people to live on our arcology. So we have 12,000 cubic meters of habitable space. This will have 4 sectors: a living space sector, an economic sector, an agricultural sector, and a utility sector. All the walls will be covered with lush greenery to ensure the oxygen cycle, and this greenery will be sustained by exploiting the capillary action of water. We will apply the technology of capillary tubes. So, the living space sector, this is considered the life of the arcology. It will contain quarters for 100 people. People from here will go to work on the other sectors. Now, we have the economic sector. The economic sector is the heart of the arcology. It is here where people from the Earth and the Moon will meet. It contains the shuttle docking section and the central headquarters, which is like the main governing body of our arcology. Next, we have the agricultural sector. This is a very critical part of an arcology because it is the food supply of it. Now, we will have terraced rows of crops, and these crops will be sustained, like just what I said, the capillary tubes. By exploiting the capillary action, which is a property of water, we can sustain these crops. Now, the question is, where will we get the water? A nuclear reactor powers the whole arcology. Where will we get the water? We have a water mining mechanism. Like I have said, just like what I have said, there's a hydroxide deposits on the north and south poles of the moon. By enforcing this water mining mechanism, we can react hydrogen with those hydroxide and will form water. And this water will be the main component of our irrigation system. And from this water, we can also extract oxygen in order to form a theoretical atmosphere generator, which will provide a livable breathing atmosphere inside the arcology. We will try to make it self-sustainable, as the water will undergo like similar to a cycle inside our arcology.
Yeah, next, food goes to the moon. It is important to make a vision.
They've all planned it out.
How to develop the society in the moon after landing. So, Weber says some qualifications. Vision. We have a vision to increase the population of the moon 4.8 billion. And to realize it, European cities of the Middle Era give us some essences. Yeah, surprisingly, they are similar in that they are surrounded by a wall. This is the example of the Trojan, Italy. Like that, we can expand our projects by connecting units around them. Now, we have solution to expand our project. Then, how to increase the population to 4.8 billion? We continue to send people to the moon, and they are living in expanded area. In our calculation, annual population growth rate, including people coming from us, is 11.18%, about 10%.
Amazing.
And in that,
Beautiful.
2175, population is about 5.5 billion. So we can achieve the goal in 125 years.
So, this is the conclusion of our project. By decreasing the demand of resources here on Earth through its depopulation, we can disperse the risks here on Earth to the moon. Then, the colonization of this other planet, of this moon, it will act like an insurance for the human race. Just as when all the mankind in the earth become extinct due to many factors, we still have many other species living in other planetary bodies like the moon. Also, the arcologies that we designed, this will be launched on the moon as the habitat for the human race. And the aim of this foundation, it has its vision to grow larger on the moon, so that one day, the moon and the earth will be like two similar habitable places for the human race. So this is our vision for the Earth. Thank you for watching our presentation. What questions do you have?